So I've got a question here that involves two further simultaneous equations. One is a quadratic, one is a straight line, and they've asked us about the line that joins the 2 points of intersection. The quadratic involved here is a U-shaped quadratic, and that intersects with a straight line. So again, a rough sketch is not a bad idea. Okay, popping the two simultaneous equations down, and happily again, where the 2 points meet, they have the same y value. So if these two y's are identical where the lines meet, it means that the right-hand sides are equal to each other. So I can say, therefore, at the meeting points, a quadratic is forming. To solve it, we need everything on the left-hand side, keeping this guy positive. Therefore, these two terms will have to move across to the left-hand side. So I get x squared. We started off with negative x here. It's joined by the 2x, which now turns negative. So this is negative 3x. We started off with negative 2, joined by a positive 2, which has now turned negative. So this is negative 4, and that is equal to 0. I don't think they're going to be unkind enough to make us involve the quadratic formula. So put down your two brackets, equals 0. I want two numbers together that multiply to be 4, whose difference in some way is 3. And hopefully you can see this is 4 and 1. That must be x, that must be x. The negative must win. So the bottom half of our eyebrows and smiles routine, hopefully it's clear that this must be a negative and this must be a positive. Let's just check. X squared, yes. Negative 4, yes. We've got negative 4x and positive x, negative 3x. So again, if this is true, either this term is 0 or this term is 0. If this term is 0, we get x is equal to 4. If this term is 0, we get x is equal to negative 1. Now we've got to do the y's. So sub in the easier of the two equations, which is equation 2. So if I put x is equal to 4 into equation 2, I get 4 times 2, which is 8. Plus 2, I get y is equal to 10, or if I put x is equal to negative 1, negative 1 causes y to be 0. So therefore, I'm going to call this coordinate b, because it sort of matches with what I've got over there. B is equal to 4, 10, and a is equal to negative 1, 0. How good or bad was I? 410. Well, that's not so bad at all. That's not so bad at all. Negative 1, 0. Well, the y value is wrong, but at least I've got it on the negative side. So not that bad. I think the sketch does help. If you can do it, fabulous. You can do it without, of course. Okay, now we know the coordinates of A and B. I've popped on a refined diagram, and I've popped on the line AB and the two coordinate points, negative 1, 0, 4, 10. Okay, and they need the exact length. There's a key word. Probably means there's going to be a square root in the answer. Well, there's going to be a square root in the answer because we're dealing with Pythagoras here. So all I've got to do is complete the triangle and work out the lengths of the vertical side and this horizontal side. Looking at the bottom, we're climbing from negative 1 up to 4. This is a journey of 5. Going up from 0 to 10, this is a journey of 10. Okay, using Pythagoras now on this equation, AB squared is equal to the two other sides separately squared. So this is 5 squared plus 10 squared. And that's equal to 25 plus 100, which is equal to 125. Therefore, AB is equal to the square root of 125, which if we look that up on a calculator, we get 11.180. Now this would be the wrong answer because they've asked for an exact length, not an inaccurate answer of a truncated decimal. So we've got to work on the square root. We need to find the factors of 125. Well, clearly, as it ends in a 5, 5 will go into it. 25. That's another factor of 5 can be pulled out of here. That's 5, 5, 1, 1. Yes, I know it's my method of doing it. You might do it. It's a tree method, but that's my method. 5 into 125 goes 25. 5 into 25 goes 5. 5 into 5 goes 1, 1, 1. So the factors of 125, so I can say that skipping over my wrong answer, that the root of 125 equals the root of 5 times 5 times 5. We can split that umbrella apart into root 5 times root 5 times root 5. And a pair of them, root 5 times root 5, is 5. So the answer, the exact answer to the length of the line AB is 5 root 5. And that is the answer they required. And there you have it.